Hello, and welcome back to AP Environmental Science. Today, we're going to actually start off with our first mini quiz question, and that is, which of the following is the most abundant fossil fuel? Now, given the title of your PowerPoint, you can probably guess what this is. That's right, coal, and that's what we're going to be talking about today. So there are lots of things to know about coal. There's a huge controversy surrounding whether or not we should have coal. Is it clean? Is it dirty? There are a lot of people who are anti-coal. There are a lot of people who are pro-coal. There's kind of a little war going on between coal and natural gas. And so there is a really complicated situation. And so what I want to do today is just go through and give you a general overview of coal. And Texas is actually a really interesting place for lots of reasons, but also because we not only have abundant supplies of oil and natural gas, but we also have huge amounts of coal. Now, in the United States, I believe it's Wyoming actually that has the most coal, the largest coal deposits, but we, have quite a lot of coal ourselves. So first of all, we want to talk about the different kinds of coal. There are three major categories and one kind of baby coal or pre-coal, right? So in this question, I'm asking you to put them in order. And by the way, in order, I'm talking about in their formation. Time and heat and pressure will decrease the amount of moisture that you find in coal. So the categories here have different amounts of moisture in them. Okay. They also have different amounts of carbon in them because of that. So the answer, as you're thinking while I'm talking, is 2. Peat, then lignite, then bituminous coal, and then anthracite. Okay. And so here's a nice little table, and obviously there are subcategories and all kinds of stuff, but basically you have peat. And if you think about peat bogs, right, like Ireland, they used to cut bricks of peat out and they would let them dry and they would burn them. That is a bog, so that is like 90% water and not a lot of carbon. So this is not a very efficient fuel source. Lignite, we have a lot of lignite and bituminous coal here in Texas, and bituminous coal. I don't know, I couldn't say that. And that is going to be, the lignite is going to have a much higher water content than the other harder, older coals. But, right, it's got, a lot more carbon than peat does. Now, when you start getting into the really useful coals, right, the bituminous coal and the anthracite, bituminous coal and anthracite can, and actually I misspoke a moment ago, it's not really about age, it's about heat and pressure, okay, and so it's really about, in that transformation, heat and pressure. So anyhow, now, the bituminous coal, it's got a lot of carbon in it, really low water. So bituminous and anthracite really have low percentages of water. Anthracite is the hardest. It is the highest carbon content. It burns the hottest out of all of those. Okay. In order to manufacture steel, you need at the very least bituminous coal, and anthracite is better, but we use bituminous because anthracite is not anywhere near as common as bituminous coal. Okay, so which of the following geological processes is not needed to make anthracite coal? This is a lovely picture of anthracite. You can see it's got a fun iridescent color. It's very pretty, very nice, yeah? So, slow or no decay of organic matter underwater, pressure, heat, time, or all of these are needed. Well, all of these are needed. All fossil fuels are going to form in places where you have lots of pressure, lots of heat, a whole lot of time, and like millions of years, and anaerobic decay of organic matter, and that is going to occur underwater. So whether it is a swamp or a lake or an ocean bed, that is where you're going to have your fossil fuels form. Okay. All right. Now, who's got the coal? Well, we do, actually. The United States has the largest amount of coal in the world. We are the number one producers. We're the number one holder. Russia comes in next. China is third. Okay. Interestingly enough, we get about 50% of our electricity from coal. China gets about 70% of their electricity from coal. Just fun fact there. Okay, so what about in the United States? Where is it? Well, hey, look at us, right? We are kind of sandwiched in between a bituminous coal seam right here and then all this lignite that runs through most of the south here, okay? And then once you get into the Appalachian Basin, you start to get higher quality coal, and then you can see over here the Pennsylvania coal is going to be the anthracite coal, okay? All right. So how do you get it? Well, when you think of a coal mine, you probably think of an underground mine, right? And when we talk about those Virginia and Pennsylvania, well, I don't know why I couldn't think of that, but when you start talking about the Virginia and the Pennsylvania mines, you are talking about underground mines right now, okay, for sure. Some of the rest of the mines are underground, some of them are surface. Surface mines are actually much more common than underground mines. So there you go. But it is typically what we think. There are three types of underground mining methods. There's the drift mine. Now you'll notice these are all occurring in mountains, and the coal is part of the sedimentary rocks. You have to get to that sedimentary layer where the coal is. And so if you can access the seam directly, you can just do a little drift mine and pull it out. You have to be careful about the mountaintop here. And a long time ago, well, not a long time ago, but prior to the 1970s, there was a mining method called mountaintop removal. And you may have actually heard of that. There are lots of movies and books and all sorts of things that are based on the idea of coal companies coming in and destroying mountains, just taking the whole top of the mountain off. And they used to do that. They do not do that anymore, right? Coal in mountains, you go into the mountain to get it. You don't take the mountain down to get it. Okay, so that's not a thing anymore, right? It used to be, but it's not anymore. Now, let's say that it's a little bit lower. You can take a slope mine, right? And you go in, and then for the deepest coal beds, you have to actually have a shaft mine. And the interesting thing about these, right, is one of these shaft, like you'll have a shaft for people, and you're going to have an air shaft because there are all sorts of problems that can occur if your mine is not appropriately ventilated, but typically they are. The other thing that you have to do is make sure that you are not having water building up in your active mine, because that would be a problem for a couple of reasons. One, your miners would drown, and that would be bad. And two, when you have lots of water flooding through here, acid mine drainage, right? The water mixes with the stuff that's actually there that you're mining and causes problems. That can actually get into the groundwater. Typically, it's pumped out and then sent to a treatment facility area, right? The discharges, okay? So anyway, so lots of issues. We are going to focus, though, on surface mining. Because when you're talking about coal, the bulk of the mining in the United States is going to be surface mining. And you can see here, remember I was telling you that coal is part of the sedimentary layers, right? And here is a coal seam, right? It's just on the side of this this is a high wall, by the way, and so this has actually been dug into. This coal is very close to the surface, okay? So this is the ground. You could walk up here. And then they just dig down. Sometimes you can find coal like 40 feet, below. Sometimes it's 100, couple hundred feet, whatever, and they can get deeper than that. But in terms of surface mining, it's going to be really close to the surface. And here's actually where they are on top of a seam, and they've opened it up. This is out of Pennsylvania, and you can see you just kind of scoop up the coal with a big grinder thing. It's actually pretty neat. This is a huge Wyoming mine. And you can see this is really, really large, and they've opened up a large area. I will say in the state of Texas, you can't do that, right? This is pretty much the width of the seam that you can have open in a Texas mine. The Texas Mining and Resources Association sort of coordinates all of mining stuff in the state. And then the Texas Railroad Commission actually regulates mining in the state of Texas. And there are very, very strict regulations on mining about how much of the land can be dug up at any one given time. And we'll come back to those regulations when we start talking about reclamation. And don't forget that you will be having a role to play in the permit application that you will be doing, right, for your own mining company that you have started. Okay, so we'll come back to that later, though. All right, so surface mining. Now, you'll hear the term strip mining, okay? Lots of people use that as a negative kind of word, but really when they talk about strip mining, they're talking about just that, cutting strips into the land to get to the coal. And so it works pretty much like this. You have these drag lines, and these drag lines are huge, right? I mean, they're amazing. When they spin, these arms can be like 300 feet long. I'm not making this up. They can be 300 feet long. The bucket over here that's full of, you know, I mean, you could have 90 tons of rock in these buckets. And when I visited a coal mine, I was with a group of about, you know, just over 20 people. We could all actually stand in the bucket and be fine. It was huge, but it travels about 80 miles an hour if this thing were to swing at full speed, right? So this is, I mean, this is one of the things that I want to impress on you is the sheer size of what's going on with the coal. Now, having said that, one of the downsides to coal is, and as is lots of things, all of these machines, they run on petroleum products, okay? And so there's a lot of fossil fuel energy that goes into mining, okay? Now, they will pull off, right, dig down to it with the drag line, and then they'll move what's called the overburden, right? That's the stuff that they pull off the coal. So here's some overburden, here's some overburden, and then they'll get to the coal seam, they'll mine that out, then they'll remove the overburden from the next layer, they'll get to the next coal seam, and you may have 2, 3, 4, 5, right, 8 coal seams that are all in a row there, and they'll dig down to get to each of them, okay? And then the overburden is actually filled back in, right? The mine area is filled back in with the overburden, and then they start reclamation, and we'll talk about that after we talk about issues, okay? So when you're talking about coal mining and coal burning, it can produce more than a quarter of the energy that the world uses, that is the world, acid rain, increased carbon dioxide levels in the atmosphere, environmental degradation, or all of these. Well, in actuality, it can do all of these, right? It depends on the mining company in many cases as to how much environmental degradation is going to occur. There's obviously a certain amount that's going to happen because there's pros and cons to everything, but the mining companies, for the most part, not all of them, but for the most part, especially companies like North American Coal, they work very hard to make sure that they're minimizing this and that they're restoring everything. But all of these either are problems now or have been problems in the past. Okay, and so when we look at this, there are some big pros. It's cheap, it's a stable fuel source, it's abundant, especially here in the United States. It's relatively easy to access, you know, sort of. And then it's really easy to transport because you just load it up on trucks and trains. And then the cons, remember, coal has a lot of stuff in it. It's got nitrogen, sulfur, mercury. When you burn it, there are particulates. And when you burn it too, you get the nitrogen oxides and the sulfur oxides and, of course, mercury. The radionuclides that are emitted, of course, greenhouse gases. And I cannot say enough, people, CO2 is not a pollutant. It is the cause of global climate change, but it is not a pollutant, right? These are pollutants. That is carbon dioxide. Okay, now what about the waste products, right? You not only have the mine tailings, which is, in mining in general, that'll be the stuff that you don't want, that you dig up. In coal mining, though, and we'll talk about other mining later on, tailings is going to be a huge problem in other types of mine. Coal works really well because the coal is all pretty much in this seam. It's mostly just coal. You pull it out, and then you can put all of the rest of the stuff back in the hole, okay? Now, the mining itself, there's the runoff, right? The acid mine drainage, those are related to each other because acid mine drainage is caused by runoff. But runoff can also be a problem because it could cause erosion in high walls and cause those to collapse and things like that. Habitat destruction, obviously, because you take the entire top off of the coal. Huge amounts of water consumption, especially when you're processing the coal. And then there's subsidence that can occur. Okay, and subsidence is where the ground actually sinks, and we've talked about subsidence when we talked about aquifers, yeah. And then miner safety. Miner safety is going to be an issue, a really serious issue, mostly underground. Okay, surface mines, everybody's got really strict safety regulations, and all of these fields, all of the extraction fields are dangerous, but the concern is really going to come with underground and mostly in developing nations, okay? So when we get to subsidence, it's most likely to occur with placer mining, strip mining, spoil bank mining, underground mining, or open pit mining. Well, if you think back to aquifers, where are those? Underground. Subsidence can occur if those passages, those shafts collapse. So there you go. Now, reclamation. In the United States, and like I said, especially companies like North American Coal, do a really good job with reclamation. And all of these pictures that you are looking at used to be coal mines. Okay, so you see they will actually go in and they will build in natural features like wetlands. If the mine is too deep, they can turn it into a lake, right? All of this was a mine. All of this was the beautiful trees here. All of this is mine. As a matter of fact, it looked like this. This was all mine. And you can actually see that there are different stages of development because remember, especially in Texas, it rolls. So you'll dig the hole, you'll fill it in, start the reclamation, and you just keep moving that in this strip along the way. And so when you're talking about reclamation, when you go to see these places, you'll see that there are different stages of reclamation. But all kinds of things, they work closely with the states. Their preference is typically to go back to native habitat, but they'll do pretty much whatever the landowner needs or wants, or whatever the city or county or state wants. Okay, so reclamation is a big deal, and like I said, they work really hard for that. And the Railroad Commission has set standards. Basically, you can think of it this way. The reclamation standards are that the land must be returned to a condition that is equal to or better than, mostly better than, it was before you started mining. Okay, so in some cases, the land is actually not only reclaimed, but restored if you were to look at its original condition before the mine. Okay, so once you get all this coal, right? So we've been talking about the mining itself and the reclamation, but now you take the coal and you want to make electricity with it because that is the goal here, is to make stuff, right? Electricity out of the coal. Okay, so you are going to want to crush the coal up, right? It's vaporized and then it's put in through the furnace where it's burned, okay, and that heats water, and the water generates steam to turn the turbine, to turn the magnet, to create the electricity that goes to your house. This is the same thing we've talked about every time we've talked about a power plant up to this point, okay. And then here is a picture. Here is a coal-fired power plant. Again, these are huge, right? This opening here is a little bit larger than, your head. And inside here is the fire that is going on in the furnace. And I have to say, I've actually been to a coal-fired power plant, and I have actually looked into the furnace, and it was incredible. I mean, it's kind of speechless there. But it was really impressive. And again, I'm not trying to get you to be pro or anti-coal. I'm just trying to give you all the facts. There are some huge pros, there are some huge cons to mining and to coal-fired power plants. But I just want to give you all of the facts because there is a tendency to report only the negative things about coal mines, and I would like to also point out the positive things. But the other thing that I can't stress enough, and it's what we talk about all the time, you have to look at how heavily society and the economy relies on whatever it is you're talking about. And if you want it to go away, you have to have something to put in its place. And if you are looking for environmental sustainability, whatever it is has to be sustainable, but also make sure that you don't have any sort of loss of jobs, that you don't have an economic collapse, things like that, okay? And so just keep that in mind. All right, so when we talk about sulfur dioxide emissions and NOx emissions and all that compared to the amount of electricity that we actually generate, you can see that even over the last 15 years, that has dropped dramatically. Part of that is because of regulation, and part of that is just because of newer technologies that people have been working on, with or without the regulations, but a lot of it is due to regulations. Yeah. So when we look at CO2 emissions, you can see that in the United States and in the EU, right, because let's not forget that Europe has coal too. I mean, Industrial Revolution, coal, London, the London fog, which is really an industrial smog kind of thing. We've had a lot of success at either keeping our CO2 levels down and some occasionally even lowering them, but mostly they've been consistent, right? China, Asia, right? They're not doing a good job. So the bulk of the CO2 emissions from coal mining and a lot of the pollutants from coal mining and all of those things are not coming from the developed nations anymore. They are coming from countries like China that don't have the regulations that we have. Okay, and one of the big ones is going to be sulfur, right? We know that we've got nitrogen, we know that we've got mercury, all that, but I want to talk about sulfur because sulfur is the cause of acid rain. Remember, sulfur dioxide is going to be the major component of the acid rain that we've been talking about that has been a problem associated with coal mining in the past. Now they work very hard to get the sulfur out, right? And so there's a couple of ways that you can do that. The first one is before you even burn the coal, you can actually wash it, right? And then you can, well, first you crush it, right? And then you can actually wash some of the sulfur right off of it. And you can also, right after crushing it, send it through a large tank of water, right, a settling tank, and the coal will float, and then the sulfur will drop to the bottom of the tank. Okay. Now there's some chemical cleaning methods. These tend to be expensive and they're not widely used, but I thought I'd throw it out there. All right. Now in combustion, the coal is crushed into fine powder like talcum powder. Okay. And it is mixed with limestone, and it's going to be injected into the furnace where it is burned. Okay. And it's really cool. It's actually suspended on these jets, these air jets, right? And so it's blown in here, it's burned, yeah? And then the limestone is going to react with the sulfur, okay? And then you can go through, you take the gases that are coming off of that, and you send them through several like stations, if you will, where they are trying to take out certain things. So here you're going to take out some of the particulate, only really fine particulate is going to remain. You're going to start removing sulfur here, right? And so when we talk about removing sulfur, we're actually talking about sending the flue gases and things like that through this scrubber, okay? And in this you have more limestone that's sprayed, and it's going to absorb the sulfur too, right? And so we're using limestone most of the time that's calcium carbonate because it interacts with the reacts, I don't know why I keep saying interacts, it reacts with the sulfur, and so you get this great situation where you have this flue gas after we've burned it that's got the sulfur dioxide in it. You pass it through these limestone, this fluid, right? It's being sprayed on it, and what you get is gypsum, right? This calcium sulfide here, that is actually gypsum, and it's going to sink and settle in the bottom, so you'll have this nice tank down here. And the interesting thing about this synthetic gypsum that forms, looks a lot like this, you can make drywall out of it. And so even the waste from the sulfur removal process actually is useful, and that's pretty cool too. So next time you are wandering around your house and looking at your walls, perhaps some of those were made with synthetic gypsum like this. Now the other thing that you want to get out is the particulate matter, okay? These are the really fine particles. And we use electrostatic precipitators for that. These are charged plates, so as the flue gas, which is an effluent, right? Anything coming off of something fluid, right, is an effluent. So as it goes through these plates, the particulates, which are already charged, are going to be attracted to these charged plates, and then they, of course, never leave the precipitator, and you can clean all that out and send the waste to landfill. That's where the fly ash goes as well. The bottom ash and the fly ash, those go to landfill too. Now, the last thing that we want to talk about here is mercury scrubbers, right? I'm not going to require you to understand what's actually going on in the mercury scrubber, but I do want you to know that it's not just sulfur and nitrogen that are removed, right, and particulates. It's also the mercury. And so very, very little, almost no mercury actually leaves the stacks, right, when you're burning coal, okay? So anyway, there's a little bit about, and it's a little bit about a lot. So we had a really small overview of all of this stuff. If you have any questions, let me know, and we're going to spend a couple of days talking about coal. All right, so thanks for listening, and I'll see you next time.